Hey everyone, today we're going to talk about section 3.4. This is on the factor and remainder theorem, and this is also on polynomial long division. The factor and remainder theorem are actually a relatively small portion of this. So let's jump right into things. In this section, we're going to look at algebraic techniques for finding the zeros of polynomials, such as the one we have in front of us. H of t equals t cubed plus 4t squared plus t minus 6. So one way of us doing this is through this technique called polynomial division. So before we talk about polynomial division, we're actually going to talk about regular long division, just so we can refresh on it, because the way that we perform polynomial long division is actually pretty similar. So if I'm dividing 1,234 by 7, then 7, then I rewrite it like this, right? I write 7 on the outside of this box, 1234 underneath the box. Then I ask myself, how many times does 7 go into 1? Well, 7 doesn't go into 1 at any times, so I move on. How many times does 7 go into 12 then? 7 goes into 12 one time. 1 times 7 is 7. So I'm multiplying here, right? This number times the thing I'm dividing by. Then I subtract. 12 minus 7 is 5. I bring this next number down. How many times does 7 go into 53? Well, 7 goes into 53 7 times. 7 times 7 is 49. 53 minus 49 is 4. I bring this next number down. 7 goes into 44 6 times. 6 times 7 is 42. 44 minus 42 is 2. So I have a remainder of 2 here. I have a remainder of 2. So this means that 1,234 divided by 7 is 176 and 2 sevenths. I take this remainder and I place it over my divisor. Polynomial division is going to be a similar process. If I happen to know one of the factors or one of the intercepts of a polynomial, then I can perform polynomial division. For instance, in this case, in the problem that we're given here, I know that x minus 2 is a factor of this polynomial. In other words, I know that this polynomial can be rewritten as x minus 2 times something. So if I just divide the polynomial by x minus 2, then I'm solving for this something. So in this case, I ask myself, so I rewrite this very similarly. The thing I'm dividing by, I place on the outside here. The dividend, I write underneath this box. So I ask myself, how many times does x, just the first term here, go into x cubed? Or in other words, what is x cubed divided by x? Well, this is x squared. So x goes into x cubed, x squared times. So I'm going to write x squared above the x squareds here. You don't necessarily have to align it like this, but this is how I prefer to align it. It helps us maybe organize our thoughts a bit better. Now I take this x squared and I multiply it times this x minus 2. So x squared times x minus 2 is, let me erase some of this stuff. x squared times x minus 2, I get x cubed minus 2x squared. And I write it right underneath this polynomial here. Now I'm going to place parentheses around this because just like in long division, we are subtracting here. And this means I need to make sure that I'm appropriately distributing this negative sign, this minus. So whenever I subtract here, let's see, x cubed minus x cubed is 0. 4x squared minus negative 2x squared. That's 4x squared plus 2x squared. This gives me 6x squared. Now I bring this next term with its sign down. So I bring down negative 5x. Oh, sorry, I didn't mean to erase that line. I bring down this negative 5x. Now I ask myself, how many times does x go into 6x squared? Or in other words, what is 6x squared divided by x? Well, this is 6x. So I'm going to write a plus 6x here because 6x is positive, right? I would have a plus sign there. Now I do 6x times x minus 2, the entire thing. 6x times x minus 2 is 6x squared minus 12x. I place parentheses around this, and I am going to subtract. Let's see. The first terms are always going to cancel here. This gives me negative 5x minus negative 12x. That's negative 5x plus 12x. That's 7x. And now I bring down this negative 14. I bring down the minus 14. And now I ask myself, how many times does x go into 7x? Or what is 7x divided by x? Well, this is 7. So I put plus 7 here. 7 times x minus 2 is 7x minus 14. I place parentheses around this and I subtract. And here I get a remainder of 0. So in other words, x cubed plus 4x squared minus 5x minus 14 divided by x minus 2 is equal to, we got x squared plus 6x plus 7. We got this thing right here, yeah? Or I could say that x cubed plus 4x squared minus 5x minus 14 equals x minus 2 times x plus 6. Let me erase here. X squared plus 6x plus 7. Good. And I can use this information to help me find the roots of this polynomial, which is actually exactly what we're about to do. We want to find the horizontal intercepts of that same polynomial. Well, so this is the exact same polynomial I had in the last example. So I'm just going to rewrite this the way I had it previously. This was x minus 2 times x squared plus 6x plus 7. And if I want to find the horizontal intercepts, I need to set this equal to 0. So this means I can set each of these things equal to 0 individually. X minus 2 equals 0. X squared plus 6x minus 7, or plus 7, equals 0. I get x equals 2, and on the right hand side, this isn't going to factor nicely. So using quadratic formula might be the most conducive to getting a solution here. So this will be negative 6 plus or minus square root 6 squared minus 4 times 1 times 7 all over 2 times 1. This is negative 6 plus or minus square root of 8 all over 2, which is negative 6 plus or minus square root of 4 times 2 all over 2, which is negative 6 plus or minus square root of 4 times square root of 2 all over 2. This is negative 6 plus or minus 2 root 2 all over 2, which is negative 3 plus or minus the square root of 2. And these are going to be my other, where my other intercepts occur. So I get x equals 2. I have x equals negative 3 plus or minus square root of 2. So if I wanted to write these as points, I could write them as 2, 0. Negative 3 minus root 2, 0. And negative 3 plus root 2, 0. Let's look at some more long division examples. This one, for instance. We have 4x squared plus 3x minus 1 divided by x minus 3. So I write x minus 3 on the outside of this box. I write 4x squared plus 3x minus 1 inside of this box. X goes into 4x squared, 4x times. 4x times x minus 3 is 4x squared minus 12x. I place parentheses around this and I subtract. I'm subtracting negative 12x, so that's the same thing as adding 12x. 3x plus 12x, that's 15x. I bring down this minus 1. X goes into 15x 15 times, so I add 15. 15 times x minus 3, that's going to be 15x minus 45. I place parentheses around this and I'm subtracting. Negative 1 minus negative 45 is negative 1 plus 45. So this is going to be positive 44. I actually have a remainder of 44 here. So here I get that 4x squared plus 3x minus 1 divided by x minus 3 is 4x plus 15 plus negative 44 over x minus 3. When in doubt, put a plus sign here between your quotient and the remainder, and then just add the sign as you get it in your remainder in the numerator. When in doubt, just do it that way. Let's look at a few more examples. Okay, this is a good example. We want to divide 2x cubed minus 7x plus 3 by x plus 3 using long division. So I want x plus 3 to be on the outside of this box. On the inside of this box, I have 2x cubed. Notice that I don't have an x squared term here. Because I don't have an x squared term in this polynomial, I need to write plus 0x squared minus 7x plus 3. I have to have this placeholder term or my polynomial division will not be correct. So any power that I'm missing that's lower than the highest power, I have to put a placeholder for. We'll see a few more examples of this. Now we continue on as normal. X goes into 2x cubed. That's going to be 2x squared times. 2x squared times x plus 3 is 2x cubed plus 6x squared. I'm subtracting here. I get negative 6x squared. I bring down the negative 7x. X goes into negative 6x squared minus 6x times. Minus 6x times x plus 3 is negative 6x squared minus 18x. Negative 7x plus 18x is 11x. I bring down this plus 3. X goes into 11x 11 times. 11 times x plus 3 is 11x plus 33. I place parentheses around this, and I subtract. And I get a remainder of negative 30. So, let's see. In other words, 2x cubed minus 7x plus 3 divided by x plus 3 is 2x squared minus 6x plus 11 plus negative 30 over x plus 3. This is another really good example. 9x cubed plus 5 divided by 2x minus 3. Notice I'm missing a quadratic term and a linear term, so I need to have placeholders for both of those. Two x goes into, this isn't nice, but oh well. 2x goes into 9x cubed. Let's see, 4.5x squared times. Of course I chose the one with decimals. Let's see, 4.5x squared times 2x minus 3. That's going to be 9x cubed minus 13.5x squared. I get positive 13.5x squared here. I bring down the plus 0x. 2x goes into 13.5x squared. Let's see, let me bust out a calculator just so I don't make any mistakes here. 6.75x times 6.75x times 2x minus 3. This is going to be 13.5x squared minus 20.25 x. I end up getting positive 20.25x. I bring down this plus 5. 2x goes into 20.25x. Let's see. 10.125 times. So I get 20.25x minus 30.375. Parentheses around this, and I'm subtracting. So I think I get a remainder of 35.375. So my answer here is that this is equal to 4.5x squared plus 6.75x plus 10.125 plus what was it? Oh, yeah, 35.375 over 2x minus 3. A few more examples. I can divide by things that are not linear also. I can divide by a quadratic. Same idea. I have to leave a placeholder for the x squareds that I'm missing here. X squared goes into 2x cubed. Let's see, or in other words, 2x cubed divided by x squared. This is 2x times 2x times x squared plus x plus 1 is 2x cubed plus 2x squared plus 2x. I place parentheses around this and I subtract. The first terms cancel. 0x squared minus 2x squared, that's negative 2x squared. Negative x minus 2x, that's going to be negative 3x. And then I bring down this plus 1. X squared goes into negative 2x squared minus 2 times. Negative 2 times this entire thing is, let's see, negative 2x squared minus 2x minus 2. I'm subtracting. I get negative x plus 3. And this is my remainder because this has a lower power than the thing I'm dividing by. I'm dividing by a quadratic, but I have a linear function at this point. I can no longer divide this. So my answer here is 2x minus 2 plus negative x plus 3 over x squared plus x plus 1. Another example. Notice here how I'm missing a linear term in my divisor here, so I have to add in this placeholder the same way I do whenever I am missing something underneath this box, which I will also be missing because I'll have this fourth term, I have a to the third power, I have a second power. I don't have a first power, so I need to have a placeholder there. X squared goes into 5x to the fourth, 5x squared times 5x squared times this entire thing, 5x to the fourth plus 0x cubed plus 20x squared. I place parentheses around this and subtract. Negative 3x cubed minus 0. Let's see, that's just negative 3x cubed. 2x squared minus 20x squared, that's negative 18x squared. And I bring down that plus 0x. X squared goes into negative 3x cubed, negative 3x times. Negative 3x times this entire thing is negative 3x cubed plus 0x squared minus 12x. Parentheses around this and I subtract. I get negative 18x squared plus 12x. I bring down this minus 1. X squared goes into negative 18x squared, negative 18 times. Negative 18 times x squared plus 0x plus 4 is negative 18x squared plus 0x minus 72. For a remainder here, I'm going to have 12x plus 71. So the answer to this one is 5x squared minus 3x minus 18 plus 12x plus 71 over x squared plus 4. Okay, and I'm going to split the recording here so I can do the next section on the last stuff from this section.